Hi there. So, in this problem, we need to determine the angle that the strings make with the vertical. So, in here we have a dice, and the first thing that we need to do is to draw all the forces that are acting on the dice. And then, applying Newton's second law, we can obtain equations for the y and the x component. So doing that, we find that we have a tension that we call T, that is due to the string, and we also have the weight of the dice that we call W. We also know that the system has an acceleration because the dice is inside of a car and it accelerates from from a velocity in 6 seconds. That velocity is that we call final velocity is equal to 28 meters per second in a time of 6 seconds. So we first are going to find the equations of for the dynamics of this. So summing the forces in the x component, we have that this is the tension sine of theta because the angle is with respect to the vertical, and this because the car is moving in the horizontal way, it is moving in the x axis, so that we will have an acceleration in this component. So this is m, which is the mass of the dice, times the acceleration. For the y component of the forces, we will have two forces, which are t cosine of theta in the positive part of y, and minus the weight. In this case, the dice is not moving in this component, so it is equal to 0. Now, from this, we obtain that the tension times the cosine of theta is equal to the weight. We know that the weight is equal to the mass times the acceleration due to gravity. With these two equations, we're going to call this 1 and this 2. We are going to determine the angle theta. What we can do is to eliminate the tension in the other equation so that we can divide 1 over 2, equation 1 over 2, so that we could see that this will give us t of sine theta over t of cosine of theta. And for the right hand side, we will have m a times a m of g. So we have that we can eliminate these two, and we also eliminate the tension, so that we know that sine of theta over cosine of theta is the tangent of theta, and then we will have a over g. So to obtain the angle theta, we take the inverse function of the tangent function for both of the sides of this equation. So we will have tangent of -1 of the acceleration over the acceleration due to gravity. We know the acceleration due to gravity because this is a value of 9.8 meters per second, but we don't know the acceleration of the dice or the car in which the dice is in. So we need to determine the acceleration. But we know from the beginning that we are given a velocity and a time. So using kinematics, we can solve this by using the following equation. We know that the final velocity is equal to the initial velocity plus the acceleration times a time t. And we know that the initial velocity is 0, and the final velocity is the one that we are given. So solving for A, we know that this is the final velocity over the time. We know that the final velocity is 28 meters per second, and the time is 6 seconds. So from here, we obtain a value of 4.67 meters per second square. So now we know the value of the acceleration. So we just simply need to substitute that value into the equation for theta, and then we can obtain the value for the angle theta. So that we just substitute those values. The acceleration is 4.66 meters per second squared, and the acceleration due to gravity is 9.8 meters per second squared. So plugging this into the calculator, we obtain a value of 25.48 degrees. And this is the angle that the strings make with the vertical.